Now you actually have the ability at your fingertips through just in some ways just through English commands to be able to go and parse through and extract and answer questions that you have that you what otherwise would never be able to answer. And that's what's so exciting about this time right now. These technologies are growing extremely fast, and we can go, we can really solve some really hard problems that were just previously unattainable.
Welcome to Embracing Digital Transformation, where we explore how people, process, policy, and technology drive effective change. This is Dr. Darren, Chief Enterprise Architect, educator, author, and most importantly, your host.
On this episode, AI, ETL, and the unstructured data problem, why accuracy still matters, with founder and CEO of Darren, Mehul Shah.
Mehul, welcome to the show.
Thank you for having me, Darren. It's good to be here.
Hey, before we jump into our topic today, which is a great topic, because I've been doing the same sort of work that we're going to talk about today, so we'll have a lot to share. And too bad if the audience doesn't care what we're talking about, because we're going to have fun talking about it. But before we get started, everyone knows on my show that I only have superheroes on the show, and every superhero has a background story. So what's your background story?
So I've been doing, my joke is I've been doing data before it was big. I've been doing, AI before it became, into the scene. My history is actually in research. I spent a whole bunch of time back in the early 2000s, late 90s, working on databases, working on large scale data systems. I was a research scientist at HP Labs, and we worked on a variety of, highly scalable, energy efficient storage and database systems, and really had a lot of fun doing it. Learned a lot about sort of trends in technology, how people use it, and where things are going. The challenge I had with just sitting there and just focusing on the technology was we were just unable to get this information, these tech tools into the hands of users every day, and getting them, delighting them effectively. We certainly created great technology, but delighting them was hard. So I created a couple of friends of mine and I started a company about 14 years ago now. It was called Amiato, and it was in the early days of the cloud, 2011, 2012. And what we saw was that there was this huge need for processing log data. At the time, it was really hard. And so we built an ETL service that would take log data, put it into databases for you so that you could run SQL over it and do your analysis. And that's what Amiato did. It was acquired by AWS. And a lot of the tools, the techniques, the ideas from Amiato turned into AWS Glue, which is AWS's flagship ETL service. So that's another joke that I often say, which is that, I've been doing ETL before anybody could spell it. ETL stands for extract, transform, and load.
Right.
So my co-founders and I, we built that service, grew it. And then I had the opportunity to just really understand a lot of what was going on in the unstructured data space by being on a platform like Amazon and AWS and Amazon Cloud. And so, from there, just, got lost in all of the problems and the solutions that you could build for your customers. I had an opportunity to run the Amazon Elasticsearch service and eventually forked Elasticsearch into OpenSearch so it could stay open. And learned a lot more about how people were doing document processing. And that's what led me to the current company that I'm running right now, Darren, where we're really helping enterprises unlock the gold mine of information that they have and the mountains of unstructured data that they have.
So all those years of data hoarding that I've been doing, right? Because I can actually do something with all that data. Because I noticed that when I go in, talk to organizations, they have petabytes of stuff that's never touched, right? Because they don't know how to engage with it, right? I think I even have I have like 5 terabytes of PowerPoint presentations and Word docs and all this unstructured data that I'm afraid to throw away because I'm like, well, I might need it someday, right? But you're saying today is the day, right? Today's the day.
I think that the time is now. So, for a long time, this market was, I would say, a market where there was a lot of non-consumption. And what I mean by that is people really wanted to, like you just described, be able to get, kind of search through their old logs, of documents, of PowerPoint presentations, contracts, um, pricing quotes, whatever you have, invoices. But they were just unable to do that. They would actually sit there and build very specific solutions for really only super high value problems. Like if this was going to be you know, um, a case that was going to be worth $100 million, let's go build a bunch of technology so that we can go through all this stuff. And so what I meant by non-consumption is you had all this data. People wanted to get to it, but the barrier to getting to it was just so expensive. Finding the technology, finding the experts that can actually get to the bottom of it very quickly, it was extremely hard. But now with the growth of frontier models, LLMs that can, not only just pull out text, but also deal with all kinds of multimodal information, um, graphs, images, video, sound. Now you actually have the ability at your fingertips through just in some ways just through English commands to be able to go and parse through and extract and answer questions that you have that you otherwise would never be able to answer. And that's what's so exciting about this time right now. These technologies are growing extremely fast, and we can go, we can really solve some really hard problems that were just previously unattainable.
Well, there's still the problem, even though it can read a document and do things like that. I still have the problem of where is my data?
That's right.
Right. And
Right.
do I want it searching through a petabyte? It'll never come back.
You know,
Right. I
that's
mean, how do I put all of that into one large language model? I
yeah,
can't do it. It's too big. It's too cumbersome.
that,
If I have a specific file, I can say, oh, tell me what this file has in it. I can do that sort of thing. But if I've got a million files, what am I going to do?
exactly. And if you're, if you're a large enterprise, you have this stuff in spades. Some of these
Oh, yeah.
these enterprises have like petabytes and petabytes of information um, that they've kind of stacked up. Some cases, exabytes of information that they've kind of stacked up. I mean, just to give you a couple of examples, um, if you're taking a look at, you know, what what our government agencies can kind of put together. Just the sort of
Like GSA is a great
GSA
example.
as an example, or NOAA, the fisheries, and so on.
Oh, yeah.
They just have so much satellite
Mm.
data, documents from applications. They have just so much information just sitting there. It's unbelievable. And right now, the state of affairs is pretty poor. The data's sitting here, and then the people that want to get access and get answers from that data, they're still, literally manually going through this information. Some of the customers that we work with, for example, um, we literally watched them. I went them just last week to see some of these customers. They're insurance companies.
Mm.
And insurance, started about a couple hundred years ago in this country, largely, around farming. And so a lot of the insurance companies and, their ecosystem is in the Midwest. Or, the farming areas in the East Coast. So Pennsylvania, Ohio, Iowa, sort of in these states. And I went and saw one of our customers, and they're really happy using our software. But before that, what they were doing was literally cutting and pasting from documents, from, from one, literally from one PDF to an Excel spreadsheet. I'm like, it's 2025. Like, you guys are still doing this? They're like, yeah, look, it's just I'm like, have you guys tried LLMs? Have you tried ChatGPT? Doesn't work. And so this is actually something that you hit upon, which is that these AI systems are really great as long as the data can fit within their context.
Yeah,
Uh,
yeah.
and
Now the
even that,
context has gotten a lot bigger, right? It has. It's gotten a lot bigger, but LLMs should stand for lazy language models because they give up.
yeah.
They,
So
they
so
don't scan a whole document. They'll find like 3 or 4 things and go, okay, I got an answer, and send it back.
yeah,
Right?
it's interesting. So certainly the contexts have gotten bigger. And I remember when I first started in this space and we started messing
It's
around with
like
LLMs back
4K.
in 20. Yeah, it was like 4K or 8K tokens, which at the time seemed enormous, by the way, because you just couldn't do anything else, at the time. Um, we certainly got, million token contexts now, about 2, 3 years later. So yeah, growing by an order of magnitude every year, which is actually great. 10 million token contexts in some of the really large frontier models and the pro models that are out there. So that's awesome. But the problem is that even though the context is available and somebody can let you stuff in a bunch of information in there, you see actually um, a quality wall. Basically, after about 100K or maybe 200K tokens, the quality of the answer just starts dropping off really quickly. You try it
I've
out,
noticed that
right?
too.
Try it
No,
out.
I've
Now
noticed
you
that. Yeah.
throw in, I don't know if you have like, a life insurance policy or something, or,
Oh yeah, yeah.
right? Or maybe you have a mortgage statement, or maybe you have, a loan package that you sent. You can send a single contract with 2 or 3 pages, it's right on the ball. It can do it. Send it to ChatGPT or send it to Gemini, Claude, and they do a pretty good job. Throw the whole mortgage application in, throw in the whole, and you'll literally see it beg for mercy. It'll say things like, well, we got a few hundred, entries out that you wanted. There's a lot more. And I'm like, okay, well, where are the rest? And this,
Somewhere.
yeah, this is kind of yeah. So personally, okay, if you're dealing with your own stuff, you can read through it. But imagine if you're processing thousands and thousands of mortgage applications, if you're an escrow company, or you're a
Yeah.
lender, and yeah, it's going to be tough. Or let's say you're a government agency, and and in the government, everything is driven by documents. I mean, Darren, you know this,
Oh yeah.
uh, right? And if everything is really just pushing paper, the best way to automate this stuff is to start using these LLMs. But right now, the token context that they have is actually quite a limitation.
Well, and like you said, even though the context windows could be large, they just the quality goes down. They give up after a certain amount of time, even though you can jam them full of a bunch of stuff. All right, so if that's a huge problem, how in the world am I solving that problem?
Well, I come from the database world. So, my background is in, building, large, reliable database systems. Um, and the trick in database systems and any kind of database system that you build is to divide and conquer. There are really only 2 or 3, great techniques in computer science, and divide and conquer is one of them. Caching
Oh
is
yeah.
another, and so
Yep.
on. Um, and divide and conquer is the best way to kind of handle all of this stuff. So, you probably heard this idea of context engineering. So there's
Oh yeah.
two different things that you can do to get LLMs to be better. Okay. One is you can give them better instructions. This is prompt engineering. Okay.
Hmm.
And then the other thing is the information that you put in their context, can be carefully crafted at the right time with the appropriate stuff, so that you can you can get them to be much more accurate. So try to make sure that the stuff that's in there fits within sort of the accuracy sweet spot, if you will, for the LLM. And then what you do after you start kind of divide and conquer is, kind of bring all of the answers that you get back after kind of interacting with the LLMs, kind of merge all those answers back, and then give it back to the user. And then this idea of dividing and conquering, how you should divide, how you should conquer, is going
Yeah.
to
Yeah.
depend. It's going to be depend on the task that you have. So if you have a very large mortgage application, you can actually use an LLM to help you decide how to divide and conquer. Say, hey, in this mortgage application, um, you know, look for where these guys are listing all your assets. Go to those pages. Now take those pages, and then I want you to answer the questions over these pages. So we call this planning, um, and you can use LLMs to do that. And so a combination of planning, divide and conquer, and carefully crafting what's in the context is a way to actually scale these LLMs. And that's what we're doing at Aaron. Fundamentally, that's what our technology is.
It sounds very similar to something I did in the U.S. Census. I learned something about LLMs with the U.S. Census when we were crunching numbers. I learned that large language models are not good at numbers because they weren't trained on numbers. They were trained on language. So if I tell it to add like a billion rows, right? I have a billion rows. I said, find me the average and give me a summation of column F and G. It does the first 10 and gives up.
That's
So
exactly right.
I did the divide and conquer concept that you have. I called it aggregated queries. And I got a lot better results when I said, hey, I'm going to take this big, huge thing. I'm going to chunk it into smaller bits and aggregate the results that I wanted from each one so I could build up. And then the last query would do, the final set. So I know the technique you're talking about. I've used it. It's wonderful. It works really, really well.
It works extremely well. Another technique that also works extremely well, if you've tried this, is to tell the LLM that you have a tool, and this is how you use the tool. So just as a human would look,
Interesting.
and just as a human would say, okay, well, I'm not going to spend, 30 hours adding up all these numbers. What I'm going to do is I'm going to use, my database, or I'm going to use my calculator, or I'm going to use my spreadsheet.
Right.
And the spreadsheet has a particular interface. The database has a very, specific interface. Calculator, we all know what the interface is the buttons on the calculator. You can also tell an LLM, here are the tools that are available to you in the process of answering this question. Here's the data. Go ahead and plan on how to use this. And so you can see LLMs. The tool use is a very common thing. You can actually try this with ChatGPT when it's going out and searching the web.
I've seen it. Yeah.
So tool use is a very common thing, and it works extremely well, especially when you need really precise answers over very specific or easy to specify problems that a database or a spreadsheet or some tool can handle for you.
So
And
the things no, go ahead.
no, I'm just keep going. Yeah.
I was going to say the things you're mentioning takes large language models from an individual person use into the enterprise, where I'm doing a lot more than write a Japanese haiku of my mortgage application, right? Which I've had people do in workshops before, right? Because a lot of people are using ChatGPT for individual work that I'm doing. But the type of things you're talking about is really turning it into an enterprise tool, right?
That's right.
Where there's more constraints, there's more data, the scale's different. So the approach is different, right?
Absolutely. And I think the biggest difference, all those things, more data, the scale, the approach, I think all those things are elements to it. The thing that's driving, all these sort of architectural decisions in the enterprise is actually one important criteria. When I work with underwriters, when we're working with analysts, we're working with estimators, so underwriters and insurance companies. I don't know if I had a chance to kind of introduce the company that I'm running right now. It's called Aaron AI. And what we do is we take people's unstructured data unstructured documents,
Mhm.
and we can automatically, using agents, extract structured data fields from those documents. And we can do that at high scale. So millions and millions of documents. And we've been doing that every day. And we can do it with extremely high accuracy. So think 97, 98% accuracy,
That's awesome.
right? And so current LLMs don't get there. They're very general machines. They can do all kinds of things, from writing poetry, to, recommending restaurants, to, extracting key information from documents. We just care about extracting key information from documents. But once you focus on that, you can get that to scale extremely well. And, to your point, the question is why are all these architectural decisions being made in the enterprise? It's actually driven by one important criteria that all of these knowledge workers have. They have to do work day after day, and that work has to be done accurately. Okay, and if it's not accurate, they're gonna either take more time to get it to be accurate, which is actually a waste of time for them. So you actually haven't helped them. Like if you get like high 80s or mid 80% accuracy,
It's not
that
good
means
enough.
15% of the time they're going back and doing their old thing. And at that point,
Yeah.
they might as well just ignore what you've given them. Okay.
Right.
It's only when you can really hit the, 97, 98% accuracy level where you're actually speeding them up. And the other thing that the accuracy helps you do, in some cases, the accuracy is now starting to get better than what humans can do themselves, is that it actually allows them to make, get build a better business, make more money. Okay. Um, so as an example, underwriters and insurance companies, their job is to maintain relationships with, brokers and carriers and so on. Um, their, their hard work right now is just, shuffling documents that they're doing. It's undifferentiated, heavy lifting.
Right.
All right. And if you can let them turn around quotes, what used to take days for our customers, we can let them turn that around in like, say, 10 or 15 minutes. Now they get more at bats and they can actually sell more policies. More importantly, they can sell better quality policies. They can sell policies that are more, that are appropriately priced for the risk that they're taking, and, better suited for the customer that's coming in. And so you actually end up building a better business if you can get higher accuracy. Okay. And that's the thing that's actually driving all of these architectural decisions that we're talking about. Because without the accuracy, sure, you can just use ChatGPT. They just throw it in, you get something back, and, maybe you keep going forward. But it's actually not helping them if you're just kind of doing it. It's a good
Onesies and
demo.
twosies. Yeah.
It's a good demo, but high accuracy is critical. Like imagine you're a securities regulator and you're going through a ton of, legal briefs and filings to find precedent.
Yeah.
Okay. What do you do today? Well, you go through a search engine, you get your top 1,000 results, and then you like literally just,
Weed
go
through
through
them.
it by hand.
Yep.
Right. We can help them basically find things that they wouldn't have found before in minutes.
So how do you handle the there's so many questions in my head right now. First off, are you using your own LLM? Have you trained a new model to do this? Or are you using an off-the-shelf one and you're doing more context engineering? What's your approach that you took on this?
Yeah. So there's a couple of
SQL.
things. It's actually a conglomeration of techniques. It's not just one thing where we can just say, this is what we do, and we just do it all the time. There's a bunch of engineering that's involved in different parts to our platform, if you will. We did build our own models to get the text, or just to get the sort of the raw data off of documents. You'd be surprised. You'd think that documents are standardized, but they're not.
Oh, they're not. I know that. Yeah.
And so Aaron can process, I don't know, some 60 different languages, more than that probably now, over 35, 36 different document types, and we keep adding them. We can do it and we can pull the text off the page, the images off the page pretty accurately and pretty fast. And there we actually built our own vision models to do it. If we found public data, we took permission data from customers and just did the hard work of labeling this, the examples and training models to do
Right.
it. But that's not enough. Okay, so that basically takes the words off the page, so to speak, and gives you
It gives me with text.
it gives you
Yep.
text, raw information, and so on. Okay, um, but we the next step you have to really do is now you have to get the LLM to really like pull out the key properties, the key things that you care about. And there we really leverage the trend there is in these large language models with these frontier
Yeah. They're
model
pretty good at that
providers.
sort of thing.
They're
Yeah.
they're good at that, right? So when ChatGPT gets better, we want to be able to get better with it. When GPT 5.2 came out, we just suddenly got better.
Yeah.
When Claude comes out with their next model, I think it was Opus, we just suddenly got better. And so we do two different things. One, and this is something that no single vendor is going to be able to do, is we actually use different frontier model providers, feed the information to multiple different frontier model providers, and then use sort of a quorum technique to be able to go and say, hey, across all of these things, are they all
Is there
agreeing?
some kind of consensus?
Is
Yeah.
there consensus or not? And you'd be surprised when there's consensus, how accurate this stuff is. And when there isn't consensus, you just haven't given it the right instructions. And so what we found is by kind of pushing the data through multiple models, seeing where there's consensus, you can see where there's certainty and uncertainty, saves humans a lot of time, okay, and being able to go through that. And then when there's uncertainty, humans can actually, like the knowledge workers can go in and say, no, this is what I want you to do. And we have a cool feedback optimization technique that takes that information from the actual knowledge workers, feeds it back into our system, and then appropriately adjusts the models, the architecture, the prompts, the context engineering. So then the next time they see the same thing, it doesn't
They go
through again.
click. Yeah.
And so, this is a technique called reinforcement learning. It's a general technique. We have a variation of that, or a specific version of that we call CORAL, correction optimized reinforcement learning. And what it is it actually, it's a technique for optimizing your prompts, where you don't need a lot of labeled data. We're actually bootstrapping with these frontier models. And it doesn't take that many iterations, maybe like a dozen iterations and, maybe 10 or 15 documents. And now all of a sudden you're getting like 97, 98% accuracy in your extractions.
I've seen the exact same thing. It's very similar to what I did with the U.S. Census, was we set the SME with the AI and a front end to it. So when they were analyzing documents, they could interact with the SME and say, yes, this is, and we've gotten our accuracy way high, like 99% now.
Exactly. Yeah.
Because you're not using the AI to replace the human, you're using it to augment the human. And so that same technique's incredible.
That's exactly right. And I think that's where, I know everybody's kind of scared by the boogeyman, like AI is going to take your job away and so on.
Well, because CEOs are laying people off and saying AI has replaced them. You can blame, all the big AI vendors for saying, yeah, we need universal income because I'm replacing everyone's jobs.
Exactly.
Of course they're scared.
Yeah, I think that's a lot. There's a certain amount of low paid, low income work that honestly, doesn't need to be done anymore, and where AI is going to help you. And the people that are doing it, they're not happy doing that work anyway. It's tedious, it's manual, and so on. And I think that this is good for everybody. That's going to go away. But people coming in and saying, "Hey, we're going to replace your lawyers and your doctors," that's not going to happen.
It's not going to happen.
You can't replace human judgment. And right now, the way to think about LLMs and frontier models and so on, they're not, they've gotten really good. like let's the greatest mathematicians, right? So the greatest mathematician that that I know of right now, and there's many of them, by the way, but the one that's sort of the in the press a lot is Terence Tao. Okay, and Terence Tao, quite a humble person for what he's actually been able to accomplish. Um, he, he a few others in the computer science theoretical computer science community are starting to use LLMs to actually start proving minor lemmas in their proofs. This is huge. Okay. But they're not going off and saying, hey, I have this idea for a proof, go off and come up with a proof. I
The
mean, that's
answer,
not
yeah.
what these, right? That is not what these LLMs are doing at all. What they're doing is they're very carefully saying, hey, I need a lemma that does X, Y, and Z. Here's a small, think of it as a subroutine in a program that I need you to go build. Okay. And I don't know if there's a recent result that I can leverage, or where there's a few set of things that I can kind of put together from the cross of, across the corpus of mathematics that's out there. It'll take me probably, a few weeks to go figure
Years.
this out.
Yeah, or
But maybe
years.
you can come up with this little small lemma. So the intuition for how to go and think about what problems to go solve and how to solve them still is coming from humans. Okay. But a lot of the sort of the work, the menial, I wouldn't say menial, but the work that the humans have to do is starting to get automated so that they can actually be more productive. Are mathematicians afraid that they're going to be obviated? Absolutely not. The greatest mathematicians still are going to be the greatest mathematicians.
Well, and in fact, they'll be able to work on problems that people have said are unsolvable.
And they'll be able to work on problems at a larger scale. So mathematicians, today, they can collaborate with maybe 2 or 3 other mathematicians, maybe at most 5, on a problem, because you got to trust their problem solving capabilities. There's got to be a sort of a culture
You
of
got to
how they're doing it,
coordinate.
coordinate, and
Yeah,
so on. But now with the ability to use LLMs, and proving techniques with things like lean, you can actually try to solve really, really challenging mathematical puzzles with a team of like 100 people. It's almost like a software project, as opposed to being, a mathematical sort of proof endeavor. And so the reason I make this analogy is, are lawyers going to go away? Absolutely not. They still got to work with humans, convince juries, convince judges.
yeah.
Um, and LLMs are not going to go replace lawyers. That's not going to happen. Are doctors going to go away? Are you kidding me? Do you want an LLM doing your surgery? Absolutely not.
You want it hallucinating during the
No.
middle.
And actually, there's a nice, observation by Terence Tao that I often repeat. I don't know if it's an exact quote, but LLMs are just getting to be better and better guessing machines. So they can guess a
That's a
solution,
good way to put it.
right?
Yeah.
But to be able to verify it, you need to have some independent way of checking their results. And you just, they're not going to be 100% right. And so in the sciences, we found independent ways of checking their result. You actually do the experiment, right? So if somebody says, this
Yeah,
is the
yeah, yeah, yeah.
protein, this protein folding, won the Nobel Prize. Here's the protein structure. Well, you do some, X-ray crystallography to go and look at the structure, and you're like, yeah, that is the structure. So you must be right. And so, there's independent ways of verifying these things. Making predictions about weather. You look at past weather patterns, you see how well it does, and you say, hey, this thing's doing good. And even in coding, the thing that is taken off like wildfire,
It
right?
has.
The thing generates all this code, but we have mechanisms to verify that the code is working, deploy it. If it breaks, pull it back.
If it's good code,
If it's
if
good
there's
code,
good design. Yeah, I've actually been teaching those techniques in my my
exactly.
class that I teach at Vanderbilt.
And so,
Yeah,
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 and
this
so,
is great.
so in the enterprise, when we're talking about knowledge workers, they have their way. They're already doing this work. They have their way of checking when things are correct. And what this is going to do is just really going to assist them. And that's really what's going on here. And I think LLMs are just going to make us much more productive. I think it's going to make us happier because we're going to be doing less sort of, grunge work,
Mundane.
so to
Yeah,
speak,
grunge
mundane
work.
work.
Yeah.
But I don't think they're going to replace humans. I think that's a long, long, long way away.
I think so too. So, all right, if people want to find out more about your company and what you guys do and want to engage, how do they reach out to
I
you?
think, yeah, absolutely. So, our company is called Aaron AI. You can just go to the website, aryn.ai, and tells you about the products that we have. You can also just, book a demo, and that'll get me on a call with you, and I'll show you what the, uh, the property, we call it agentic property extraction system does. Um, and I'll tell you about all of the, cool, technologies that we built. So feel free to just go to the website, or you can just send us an email at info@aaron.ai.
That's awesome. Hey, Mehul, thank you for coming on the show today. This has been great. We could go for another hour easily, but people would be bored. We wouldn't. We'd have a lot of fun. But thanks again for coming on the show.
Darren, thanks for having me, and I'm looking forward to seeing the podcast. Talk to you soon.
Thanks for listening to Embracing Digital Transformation. If you enjoyed today's conversation, give us 5 stars on your favorite podcasting app or on YouTube. It really helps others discover the show. If you want to go deeper, join our exclusive community at patreon.com/embracingdigital, where we share bonus content and you can always connect with other change makers like yourself. You can always find more resources at embracingdigital.org. Until next time, keep embracing the digital transformation.